Greetings everyone and welcome to another episode of Road to be Proficient in C, and on today's challenge we have one-dimensional arrays. So in the objective we have a description about how to structure an array. It says that an array is a container object that holds a fixed number of values of a single type. And this is true in C, in Python it's not true. If you want to fill an array, it should be the same kind of objects. You cannot put double and int on the same structure. The data type array contains only one single type. If you do want to create an array in C, we do it that way. We say the type of the array, the single type of object, and then we'll say the name, and then in brackets how much numbers that we will have in the array, we will store in the array. This is the static one. In C, here array is the variable array which holds up to, I think they want to say n, because as n here, maybe it was an old example with 10. So this was a static example, like you have only 10, you can store only 10 variables. If you want to do it dynamically, let's say that you want to allocate first 10 variables and then you want to put 12 or start dynamically increase the size of the array. You do it in that way, you do it with pointer, and you need to know that both of the cases, the base of the name of the array is, you can use it like a pointer, like here is a pointer that points directly to the first element of the array. So here, in order to explain you this syntax, it's simple. This is an integer pointer. We need to cast it with integer pointer because we store it in integer pointer array. This function here, we use it in C in order to allocate memory, and we have n times the size of int. Because we store int, we need to allocate n times the size of the int, if it makes sense, which means we need 4 bytes for each of the numbers that we store. So in that way we can say like store like n times 4 and send the integer pointer of the first element to this pointer. I hope it makes sense. In order to free the memory, we use the free to deallocate the memory and the base name. If you want, I don't see here to say to make the array bigger. If you want to make an array bigger, there is another function called realloc, and you realloc your size of the memory, and I think you copy it, something like that. I can't remember exactly. If you want to see it more specifically, you can type it realloc and you'll see how they do it. Input format, the first line contains an integer n. Okay. The next line contains n spaces separate integers. I think this is the size of the array and this is the elements. So we have 6 here in the input, 1, 2, 3, 4, 5, 6 elements. Same thing here. And we do a sum, or we print the sum of integer in the array. Okay. So we are here. So in the first line we have a scanf, as we know. So read the size of the array. Read the elements. to the sum. Print. So here in the read section of the our code, we'll use int n will be scanf precedence d and we will give the argument yeah, we need to pass the address. So now we have our int. Now we need a loop to read all the elements. First, we need to make an array. We can do it both of the ways because we already know the size. We don't need to make it dynamically. But I will try to show you both of the ways. It will be good practice for me too. So int, we have the name of the array, we have the size of the array, right? So this is the static allocation declaration of the array. And now we need to make a for loop from int I equals 0. We say I less equal when, and we increase the I. And we say R I equals N. Sorry. Interesting. So we will use the pointer nevertheless, because here we need to pass an address. So we need to pass the address of the first element. So in the first one it's easy. We know that if we pass the R in the scanf, sorry, we will read something like that, right? And then here we need to pass an address of the element. We know for sure that we can pass this one, and this is the first element of the array. But the thing is that in the next one we need to go to the next element, right? So we can do it like this, like so, like I can't remember. I remember how you do it exactly. Yeah, I'm stupid, sorry. We do it like so. And we can do it that way. So every element will be, and if we print it like printf and then c space position I, we should get all the elements. So let's make a test run. 16, 13, 7, 2, 1, 12. Oh, we go one, yeah, we go until n. So this is interesting. It printed the address of the next memory because it was free. If it wasn't free, we would be able to access to the next element of the memory. Like, so we have 6 boxes here, all of them sizes of 4 bytes, right? But due to the fact that we went one more step further to the memory, we access the next memory, and in the next memory we had the address, this address here. So as you can see, this is a way to make exploits when you are a hacker in C. People made some exploits with gets because they was reading memory that normally they wouldn't be able to do. So keep in mind that those things can happen in C if you are not sure. Careful if you're not careful. So if we run it again, we should get the example. Yeah, as you can see, we have the same thing. So now we have the array here. We have it already. I will show you the dynamic array way. So int pointer array, we need to cast it to the type of the array that we want to allocate. So int pointer, we write malloc, and now we need to allocate the size of the array, which is n times size of, and the expression of the type of the array, the type that we want to allocate. So int here, we use int here, and we are good. And the loop will be the same. However, it will be a little bit different here. So here we have the address and array and the index of the array. Now we will go somewhat differently. We will increase the pointer and now we're good, because here the pointer points to an address, right? The content of the pointer is an address, and because we have the first element of the address, we need to go to the next box, which is the next address. So this thing here will give us an address, and we don't need to put reference here in order to take it. So if we run it, we have an error. Excellent. Yeah, we don't increase the pointer. No. We do it afterwards. We don't print anything. Print. Space. And we need to take the content of the address. Put this one. So we printf a digit, and here in the place of the digit will be the content of the address that we point to. So if we run the code, yeah, I don't know why. So we are 4 here. And we go 8 bits. The address is correct, right? You see, we allocate 4 bytes. So if you see here, we go 8 bits every time, up and up and up. Sorry, 4 bytes every time, up and up and up and up. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. So we have the addresses, but it doesn't contain the right value. Should we do it after the print? Here, pass the array. I don't know. Sorry. Yeah, that was our mistake. So we have 2 ways to increment a pointer. To use a ++ sign afterwards and ++ sign before. Actually, you can do it if you can do it for like. Is clever enough to know that that if we increment this array, because it's a type of int, we need to go 4 bytes forward. So if we say like here, it does something like that. So we can do it too, like so. But here it increments the pointer first and then does the whatever it needs to be done. If it's after the ++, it does what he does and then increments the pointer. So anyway, now we have our list correctly. Now we need to add all the pointers. So we will need a sum here variable int sum 0 for int I equals 0. And by the way, we could do the sum here directly without allocating an array, but as our object task says, we need to make an array at the beginning. We need to make an array. Int sum 0 again. I less than n. I plus plus. And now we can say sum plus equal, same thing here. An array, and then we can increment so if we print the sum here, I'm a little bit worried because we increment the pointer here. Maybe the pointer now points to the last address, so we need to reverse it back to the beginning, but we will see. So some and we need to delete this print here. And if we run it, yeah, we need to reverse. We need to reverse it and go backwards, like, and Anna, but we can go backwards, like. Now we have 16, 9, 2. Why is that big? So we are here. Maybe so what happens in the last loop of this one? We increase the array, the pointer one more time. So we are in 12, and we increase it 1, and then it makes the change. And then we break the loop. So if so now we should have the correct answer. Pretty sure that this is it. Yeah, that was it, but why this doesn't work? If my eye it wasn't increased. So we could do it like if I plus 1 I think now we should do. Yep. So if we submit, it passed all the cases. That was it. I will hope you like it. And if you do like it, please hit the like button because it helped me so much to keep going, and see you in the next one.